So, welcome. This is a very large audience. I'm used to smaller crowds. The slides are online at that URL, talks.php.net, Vienna, 17, like all my other talks. I'm on Twitter, @Rasmus. So, I've been doing this for a very long time. I am older than most of you in here, it looks like. This was me starting out hacking on a Commodore VIC-20. I actually had a computer before that as well, but I started doing my real development on the VIC-20, if you can call it that. I dreamed of getting a 2400 baud modem back then. This was pre-internet. There was no web when I was doing this stuff. And this was my world, Z modem, downloading things. In the 90s, I played a lot with Gopher, which was kind of the web before the web. And the world changed in 1993 when Mosaic came out. This was when the web hit, the first graphical browser. And as soon as I saw it, I finally could explain to my parents where things were going. I tried to explain Gopher to them. They didn't understand Gopher. They said they would never use Gopher. But when I showed them the graphical web, then they could start to understand. And I knew instantly that this was what I had to do. Unfortunately, in 1993, programming the web sucked. This was a CGI bin program written in C. And it's C code where you have to go and you have to change the C code and recompile if you wanted to make even a slight change to the actual web application. That was terrible. A lot of people started using CGI PM, which is a Perl module for Perl, to develop web applications. It was slightly better, but the problem was, first, it was pretty damn slow. You had to fork and exec a Perl interpreter on every request. This was way before mod Perl. Plus, you were still programming your HTML. You still had to write Perl code to spit out HTML. I didn't like that at all. So PHP, really, what I wanted a simple templating language that was built into the web server. So I didn't have to fork and exec another process. But the web server itself could read HTML like any other, but then do intelligent substitutions. And you could inject your own code via C into it. So the way I saw PHP, and this wasn't how it turned out, but I saw PHP as a very thin templating system on top of business logic written in C. And I provided a very nice API, or so I thought, for writing all your business logic in C and then just doing the front-end stuff, just doing the actual display logic in the templating language. The world disagreed with me. Nobody wanted to write C. The web grew so fast that people completely ignored the entire C layer of this architecture. They wanted to do everything in the stupid little templating language that I had written. They wanted to write all their business logic in the templating language. I was like, what are you people doing? Is this not a strictly typed, compiled language? You're nuts. You cannot write an entire application in a templating system. You have to write the actual real parts. The core of your business logic should be in a strictly typed, compiled language. This is crazy. But PHP grew, and the number of people using the templating system was just crazy. And part of this was because the web grew so fast that there just were not enough developers to feed this insatiable hunger of this exploding web. And all these pseudo-developers who were tasked with developing the web, they didn't want to learn C. That takes a long time. C is complicated. You have to figure out pointers and complicated stuff like that. This little templating language that I had written, people could understand that. They could add one little thing to an HTML page, and they could reload their browser, and hey, it worked. They didn't have to compile anything. It was just easy. And then they started asking for more and more features and more things they wanted the templating language to do, and I kept trying to fight back, saying, no, this belongs in the business logic layer This should be done in C. It's like, no, we need it in the templating language. And this is how we got PHP. We got a templating language with business logic features kind of shoved up into it because that's just what people wanted. And when people, I mean, it's the community that built PHP because I couldn't do it alone. So people joined the project in order to basically push these features that they wanted. And that's what got us to where we are today. And we're in 2017, PHP 7. We have managed, I think, with PHP 7 to finally actually make it work. So it is now super fast. If you're still on PHP 5, you really need to get off of it. Everything will go at least twice as fast once you upgrade, and you'll use a lot less memory, which means your server density, you can spin up fewer AWS instances or whatever you're using. You can shut off half your servers, which is really, really nice. We didn't do it with a JIT like the Facebook folks did. We basically started off in the JIT path, but we noticed, we wrote a JIT. Well, I didn't write a JIT. Dimitri wrote a JIT. And we noticed with Dimitri's JIT, it didn't help out anything. We could generate fractals really fast, but WordPress and Drupal and all the other apps out there didn't speed up at all. And with a lot of profiling, we figured out we're just using way too much memory. We're copying too much around. So the focus shifted away from the JIT and just to reduce memory use and to make more efficient use of CPU registers and things like that. And it worked amazingly. We were actually surprised how well or how much we were able to save and how much we were able to speed up PHP 7 simply by reducing the amount of memory that we needed. And a drastic example of this is that this stupid little piece of code that generates 100,000 arrays of arrays. In PHP 5, this takes 109 megabytes of memory. In PHP 7 with opcache enabled, it drops to 6 megs of memory. So you go from 109 to 6. This is a massive reduction in memory use. And we ended up doing all kinds of other optimizations that you can read about. The JIT, it's still out there. We're still plugging away at it. It will probably make its way into maybe PHP 8, 7.3, something. It's not going to be in PHP 7.2, so it's not coming out this year. Maybe next year or the year after, and then we could expect a significant boost as well. As it is, you can kind of see the progression. 2009 was PHP 5.3, so this is running WordPress, the latest WordPress alpha release. I just did these benchmarks a couple of days ago. Running that on PHP 5.3, 154 requests per second. Running it on the latest PHP 7.2 that's coming out this year, 540 requests per second, right? So at least for WordPress, if you're still running PHP 5.3, I think the minimum version for WordPress is still 5.2, but I can't even compile 5.2 anymore. I'm not sure who the heck is still running 5.2. So if you're still on one of the PHP 5s, you're kind of lucky, because you have this amazingly free boost coming very soon, hopefully. The FDO stuff is a way of training your binary, so getting a little bit extra boost out of it. It's called feedback-directed optimization. It's a GCC feature, and if you're really geeky and you have a very specific load, so if you're just running one application on your servers, you're not an ISP, then you can tune your PHP to run that particular application really well by following these steps. WordPress memory, you can see as well with these versions that we used to need about 140 megs of memory in PHP 5.3 to run WordPress. Now we need 15. And this is actually for 10 FPM processes running, so it's the collection of 10. So each one is like 1.5 megs of memory. But the server needs about 15 to run 10 processes now, which is a huge drop, almost a 10x drop in memory use. The real-world effect of this, so this is graphs of Etsy's upgrade a couple of years ago from PHP 5 to PHP 7. So this is response time. PERC95 response time, or the latency, the time between the request hits the server and the first byte comes back, it dropped from about 480 milliseconds to about 270 or so a little over 200 millisecond drop in latency upgrading to PHP 7. CPU dropped as well, pretty much in half. So we were able to serve pages twice as fast in using half the CPU. And memory use dropped from like 80 so megs down to 12 megs of memory, which also meant that we needed a lot fewer servers, and we could put more concurrent requests on the servers we had, and we could turn off. When I was testing the upgrade, I started turning off servers. And once I had turned off half our production servers, the ops team were kind of wondering, wait a second, what's he doing? And I started turning off more servers, and it's like, stop, what are you doing? You're taking down all our production servers. Are you crazy? When I had taken down 3/4 of all our production servers, the ops team said, oh, okay, that's it. You're not allowed. But performance was starting to degrade, but it didn't, even when I turned off 75% of our production servers, it was still running faster than PHP 5. It had degraded from PHP 7 levels down close to PHP 5, but I was still slightly above PHP 5 performance levels, turning off 75% of the production servers. And that is the real key. Twice as fast performance is nice, but being able to turn off 75% of your servers, imagine if the entire world did that, right? The impact that that would have. So a little bit of math around that. There are around 2 billion sites running the web currently. And those 2 billion sites sit on about 10 million physical machines in data centers all over the world. And PHP is on at least half of them. So currently, we're only at about 5 to 6% PHP 7 adoption on all those machines. So on about 250,000 physical servers, people have upgraded to PHP 7. At 3,000 kilowatt hours per year, that costs about $400 in the US at least, plus data center cooling to cool all these servers, we're spitting out about 0.5 kilogram of CO2 per kilowatt hour. At 5% adoption, that's saved about $200 million, 750 million kilowatt hours, and we're spitting out about 375 million kilograms less CO2 just from 5% adoption of PHP 7. If we can get to 100%, we can literally start changing the world and making the world a better place. So, damn it. All right. So, if I can't guilt you into upgrading to PHP 7, maybe I can provide a little bit of a carrot. There are tons of really cool features in PHP 7. You probably have gone through and seen most of them already, so I'm going to go a little bit fast. Exceptions on fatals, so most fatal errors are now actually exceptions, so you can catch things. So if you're doing an eval and your eval code calls something invalid or has a syntax error, you can actually put a try catch around it and you can continue on. If you ended up calling a method on a null, which you end up doing all the time, you can also recover from that. In order to not break backward compatibility, we shuffled the exception hierarchy slightly so that all your existing PHP 5 code will run exactly the same, even though fatal errors are now exceptions. They will still act like fatal errors because they will be uncaught, even if you have a try-catch around things, because we have introduced this sister class called an error exception that sits next to exception. So you're not actually, if you're catching all exceptions, you're not actually catching these error class ones in your PHP 5 code. So your PHP 5 code will run unchanged. You have zero reason not to upgrade because all your PHP 5 code, pretty much, there are a tiny few exceptions, but all your PHP 5 code will run unchanged on PHP 7. Return types, this is the syntax, colon, the type that the function's supposed to return. If you get it wrong, you get a type error exception. which is fatal, of course, if you don't catch it. Cursive scalar types and strict scalar types, meaning you can now put types on your arguments, scalar types on your arguments coming into functions. If you don't turn on strict types, PHP will convert these types, so you're guaranteed to get these types inside your functions and methods. If you want to be really strict and have fatal errors if people get it wrong, you can turn on strict types, and you will get type errors thrown if people pass in the wrong things. Anonymous classes, just like anonymous functions, basically you can spin up classes on the fly and throw them away. Personally, I've never had a use for this, but there are framework folks that say that this is very important. I am still a little bit dubious, but it was easy to implement, and and people smarter than me have said, yeah, it's useful. I'm like, okay. Coalesce operator, personally I like this one because you don't get notices for undefined variables, so you can very easily put in default args. So what this does is if this is set in the PHP sense of the word set, it'll return the first set variable. So in PHP, if you set something to null, it's kind of like undefining it. It's not considered set if it's set to null. So in this case, A or B. B is set to 0, so this is going to return 0. C or B. C is 2, B is 0, so you're going to get 2. Now, A, X, or C, so X isn't even defined. The nice thing here is you don't get a notice on that. It'll just go and return 2 in this case, because A is unset, X is unset, C is the first one set. I use it a lot for default arguments, for like a get method variable and then default. If it didn't come in via get or post, then this should be the default, instead of all the if empty, if is set type boilerplate code. Spaceship operator, mostly because people were getting these comparison functions wrong for user-defined sort callbacks. You can just use a spaceship operator and it'll do the right thing in a sort callback. And we've removed a whole bunch of PHP 4 stuff. If you're still on PHP 4, tough. Your code is toast. You can, if you really are still on PHP 4, I would suggest upgrading to PHP 5.6 first, because it'll then show you all the deprecated stuff. You'll see all the warnings about things that were deprecated. So go to PHP 5.6, get your stuff working on 5, and then make the jump to 7 the next day. There's some new reserved words. So if you have classes named bool or string or resource, it's going to break. So fix those. 64-bit interpreter support. Various little edge case things in here. Some of these were actually a lot of work, but unless you're running all your stuff on Windows, it's not a big deal to you. This one will mess you up. If you have some really complicated pieces of code, something like this, for example, right? So you have a dynamic function call, a variable function call that returns a closure, that returns an array. You want to get this array element, and inside that array you have another set of closures you want to call it, right? You do all these things in one go. Don't do that. But if you do, you have to recognize in PHP 7, this might behave slightly differently, because now everything is left to right. So it will start expanding this thing. It'll expand this first and figure out, well, what is $foo? Okay, $foo is bar. Now I'm going to call a function named bar. Now that bar returns an array. Okay, I'm going to look it up via the bar index, and it'll continue like that, left to right the whole way through. PHP 5 was a little bit inconsistent in how it handled these complicated expressions. So if you have stuff like this, go back and add in curly braces to make sure that, hey, I know I want this executed first. It'll work perfectly in PHP 5, and it'll work in PHP 7. And that way, it will be preserved. Otherwise, if you don't put these in, an example like this, for example, will break going from PHP 5 to PHP 7, because PHP 5 would expand this first and then use that value as the property name. Whereas in PHP 7, this is the property name, and then it tries to dereference the array. So you have to be careful of that. This is the biggest breaking change. when I first started looking out on GitHub and I downloaded all the application frameworks and PHP applications I could find, I only found one out of about 40 or so, one instance of an actual public project that got hit by this. Oops, sorry. It's not as big a deal as you think, and there are tools that can help you fix it. All right, some Unicode stuff, new crypto safe, PRNG, random int, random bytes, very useful if you're doing random stuff and you're trying to do it via OpenSSL or one of these other libraries. This one picks the best randomness source on whatever platform you're on, so you can safely just call random int or random bytes. 7.1, some additional features in there. You can go and look at my slides. I'm not going to have time to go through all of them. And a couple of new things. The break from 7.0 to 7.1 is minimal. A couple of new keywords. We've dropped support for SSL v2, some of the normal things. The biggest one, I guess, is mcrypt. Mcrypt is an ancient crypto library that people shouldn't be using anymore. If you're still using it, start getting off of it soon because we're dropping support for it. Another project I've been working on, static analysis, can help you with this migration from PHP 5 to PHP 7. First of all, it'll catch really dumb mistakes. So it's kind of hard to even spot this one. It looks okay, right? But if you notice, they probably meant to put the brace here, right? If count is greater than 1, as opposed to if count A greater than 1, right? But static analysis, this is syntactically valid, right? If A is greater than 1, this is going to be true. Count true is always going to be 1, right? So it's always going to echo test, no matter how many elements are in the actual array. This can catch it for you. It can check your PHP doc comments. So here it can go through and say, hey, var int param string arg, you're passing in the wrong type as per your comments here. So it can make those sane. And it can help you refactor. You can drop a deprecated comment in on a function, and you can very quickly catch all the callers. You can very easily install Composer require. You can create a config where you set various configuration options, and then just run vendor bin fan, and that will then scan your project directly. We use it a ton at Etsy. So whenever we have this try system that basically runs all our unit tests, and one of the things it runs is a fan scan of all the code. So if you've made a stupid mistake, the static analyzer will let you know. And those unit tests also run before the push to production. So it'll catch dumb mistakes before it hits production code. It can also help you with type safety. If you're trying to go towards the strict types in PHP 7, it can be daunting to change completely untyped code to strictly typed. If you have stuff like this and you start doing strict right away and you toss in both types on the arguments and the return values, it's going to be tough. Because you don't want your production code breaking for production use, right? So what you can do is you can use static analysis and you can put in these types, kind of like soft types in this sense, and then catch it just via static analysis. And once your static analysis is clean, then you can start moving towards full strict types, and you can do it gradually across your code base. All right, 20 seconds left. Again, slides are there. Talks to PHP.NET, Vienna 17. I'm not going to have time for questions, I don't think, so I'm around. I'll be around for the next couple of hours, or maybe an hour or so. Catch me if you have something that you'd like to talk about. Other than that, thank you very much.